Welcome back to another episode of the Modern Farming Podcast, brought to you by the Green Gene Foundation, where we cultivate agricultural excellence through education every day.
We're Chris and Tara, and together we're growing knowledge about the world that feeds us.
And today is a very interesting and educational piece on regenerative growing processes. We welcome back our friend Brad Turner from Sand to Soil Services to continue on his series of informational episodes on soil health and the proper regenerative growing techniques. Welcome, Brad.
Welcome.
Hey, good to see y'all. It's been a little while.
It's been a bit, but we're glad to have you back.
Yeah, no, this one will be fun. I guess we're kind of carrying on we talk about all the different things it takes for growing, and we're going to dive into biostimulants and inoculants, which is kind of the fun part to me.
Yep.
So yeah, we'll dive into that and have a good time.
Excellent. Before we start down that road, can you just give the listeners a little bit of a quick 30-second review of what we've talked about so far with your regenerative series?
Yeah, I think we started with compost, mulches, and manures, and so that's kind of a way to put heavy amounts of carbon into the soil. Some of it's stable, some of it's not stable. That's also getting fertility into the program, and then just bulk levels of carbon, and then biology also, of course. And then we had one on cover crops, which is one of my favorites, and that's pumping lots of good carbon into the soil, whether it's from the biomass of what you're growing or the biology that you're waking up with the root exudates. And that one's not adding fertility necessarily, just recycling fertility. But those are the two main drivers, those of getting large amounts of carbon into a farming or ranching situation. So today we're going to talk more about biostimulants and inoculants and what they are, what the difference is, those kind of things, how they work.
Yeah, I'm excited to hear about how what it is and how it works. And please start, Brad.
Yeah, let's start with what. So the folks might not be 100% familiar with the term biostimulants. So can you kind of define that for everybody, and then we'll go from there?
Yeah, I think in the regulatory world, they put all this that we're going to talk about in the order of biostimulants. So it's the way I think of it, I think of biostimulant as something as the food. So whatever the carbon source is, it's actually feeding biology that they can eat like right now. So that's what I think of as a biostimulant. And then on the bug side or the microbial side, whether you're waking up native species or whether you are adding like a bugs in a jug type product or inoculum you've made, then I think of that as the inoculum as the actual microbes. So I'm not sure what's correct. Some of them just call it amendments, different amendments. But so we could talk to both of those, what feeds them, what's good, what's best, what's better, and and then adding biology to a growing system.
Okay. Cool. So for biostimulants, you kind of have two different sides, right? You've got the food and the biology that goes in the soil to process that, and then that biology works with the plant. Is that correct? So you've got kind of three different things happening.
Right. Yeah, like back to the cover crops. I mean, when you're putting out root exudates, that's kind of like the ultimate biostimulant, because that's the plant regulating and knowing what it needs to put out to wake up biology to bring back nutrients to feed the plant. Probably the first thing to talk about is carbon. So it's, they're eating carbon. So you have labile carbon, which is unstable carbon or liquid carbon. That's something a microbe can eat right this minute. And then you have recalcitrant or just unavailable carbon. That would be biochar. It would be considered an unstable carbon. So that makes a good home for them, but they're not really feeding on it.
Okay.
So when we're in the ag world, we're thinking about, compost is going to have some available carbon in it. Not a lot, not as much as people think. A lot of that is more unavailable carbon. Oh, so we're in an ag system. We're going to be adding. You can add sugars. You can used to use a lot of molasses. You can feed humic acid, fulvic acid. Can help feed biology. I don't think, in my opinion, it's not the best food source, but they're good for humics and fulvics are really good for etching fertilizer off the colloid. So just like washing it off. It is an acid.
Okay.
I used to use a lot of fish. Fish is great because you've got the food. Anything that comes out of the ocean and rivers, lakes is going to have most all the trace elements and micronutrients in it. So you're getting a little bit of that. So
you're talking a fish slurry, not a whole chunk of fish, right? Just to clarify.
I've done chunks of fish. I mean, I've cleaned fish and then sling it out on the garden, or if you want to take the time to run it through a blender, that's just a good, like, fish emulsion, fish hydrolysate. It's all good, just like the Pilgrims did.
Yeah, Pilgrims, the Native Americans, right? That was their trick when they planted. They used their fish scraps.
Yeah. And Brad, are you talking about just laying it on the soil or tilling it in, mushing it in? I mean, what procedure would you do if you're going to add fish to your garden, or fish emulsion or something like that?
Yeah. If you're buying fish, fish emulsion is a little hotter. It's mostly a fish hydrolysate that you would buy, and you can, all the garden centers will have some. You just spray it on the soil, put it in a watering can in a garden situation. In big ag, all this stuff usually is going to be injected, through the irrigation, or laid down in a bed. If it's not a no-till situation, I just spray it on in a pre-bed situation. And a lot of this stuff can be used foliarly too, and we'll talk about that in this podcast a little bit later. But those are kind of the main ones. And then seaweed and kelp are very popular. I used to use a lot of seaweed and kelp. That one you have to be careful with. It's got all the micronutrients, trace elements in it, but there's a lot of hormones in there: auxin, cytokinins, gibberellins, ethylene, and they're hormones. So you can overdo something like a kelp or a seaweed, especially if you put it on foliarly on the soil. It's relatively safe, but anytime you're messing with something that's hormones, you can promote a growth of just a flush when you might need flowering. So you just got to be careful with certain kinds of seaweed, kelps. They're great materials. They feed biology. You just don't. I mean, fish, you can hammer it. I mean, you can put a lot and not worry about causing too much harm. Don't use fish a lot in the conventional world because it gets expensive. It's wonderful in the organic world because you're getting nitrogen, phosphorus, and potassium out of it. And so that's how a lot of certified organics will get their NP and K needs is with a lot of fish.
Okay.
In the conventional world, when I work with clients, I'm still working with fertilizers because I can do that. I can get my NP and K cheaper when we're doing on a large scale. And that's when, we're just trying to figure out the safest, the best for the time, the growing season, whether you're in bloom, whether you're in growth, whether you're in fruit field, there's different forms. But in the conventional world, we kind of use NPK fertilizers, and then we just work with carbon and biology to process those nutrients better.
I have a silly question about the fish.
Okay.
It's only because I don't know anything, but I've been learning to compost, but I've heard that you don't put fish or animal proteins in the compost. So are we only talking if I had like if I'm cleaning my fish and I'm getting ready to bake them and I have all this debris, that I could just put it on the garden versus putting it in my compost bin. Is that better?
And I never did put any meat scraps or fish or anything when I was making compost.
Right.
You can. I mean, Joel Salatin puts whole cows in his compost piles once they're really working, and
really?
It devours them in a matter of days. So it's
because he has such a big pile, though.
Yes. But if it's working well enough, I mean, theoretically, if all the biology was firing and doing what they're supposed to do, you could put the fish in that and it would consume it pretty quickly, and it would do good things. I just always stayed away from meat scraps, because if you're not doing it correctly, then you can get rot, and then you got a mess, and you got flies and maggots, and so I just always stayed away from meat in compost.
And I do, but if I did want to put fish around my garden beds that are like not being used right now, the ones that are not being used or the ones that are being used,
you could do both. I mean, ideally, you'd probably scratch a little furrow and put it, cover it.
Okay.
It's going to break down faster.
Okay.
I used to put it in. You can put it in a blender, a food processor, and that's just going to make it, effective faster.
Available
it's
right
easier
now.
to break down. So, but no, guts, head, eyes, everything, bones. Yeah. It's all good.
Okay.
Yeah, I would recommend grinding it up.
It's been through that process, so it's in a liquid form, but it's the whole fish. It's everything.
Okay.
I would grind it up as much as you can, because I know over here, if I put whole fish in my garden, I'd have cats, raccoons, possums, birds. They all can smell that, and so that was the only thing I'd worry about is you're going to feed the wildlife if you just put fish heads out there. Yeah.
Okay.
But yeah, that's pretty much the biggest. I work a lot with organic acids, which humic and phobic are organic acids. They're mined. That's linardite that's been mined. And we can dig in. I like to dig into these because I study all these components a lot, because I use them a lot. On the humic acid side, that one's real popular. That technology's been around for decades. People used to sell a lot of liquid. They still do. I'm not a big fan of liquid humic acid. I worked at a place where we used to make it. Had a big vat, and you'd put the granules in, and then it went through a big heavy long time circulating thing, and it would turn it into a liquid, and then you had humic acid, which does a lot of good things. Not the best of food. The downside, and then I'll get off of this one. The downside to using liquid humic acid is when you get all done, there's this little black layer at the bottom that won't go into suspension or go into liquid. And that's like the best goodie out of the whole thing is left in there that usually gets dumped out. It's called oleic acid. And if it's in soil, the biology can break that down and do all those wonderful things that particular acid does. So when I'm making recommendations with humic acid, especially on a large scale, the best way to do is to take humic acid granules, put it in your compost, and leave it in there as long as you can. Blend it in there for a week, a month, and then that will start breaking down in the compost and release all the goodies in it. So that's how I like to use humic acid, is still in the granular form, ideally with a compost or in a manure.
Okay.
So, and if you want to dive deep into any of the others I mentioned, we can dive right in.
Well, I think so. Where we saw use humic acid a lot was right after this latest freeze. I think there was some studies that say it helps wake up some of the things before you really attack your plants above ground. So maybe could you talk a little bit about the timing? When's the best time to do this inoculations, these biostimulants? Is it anytime? Is it we've got a lot of listeners that are coming out of winter right now. Is now a good time for most people when the trees are coming back, plants are coming back to life.
Yeah, in Florida, where we don't have frozen soils, I really think anytime and all the time when you're talking about feeding the biology, because the biology is not going to force anything to the plant that it doesn't want or need. So if you're just feeding microbes, then the plant and the biology is going to regulate, what needs to be taken up when. If you're putting, say, a biostimulant or an inoculum with a fertilizer, that maybe could push a little bit that you didn't want to at the time. But for the most part, when we're talking about microbes, inoculums, and biostimulants, that's just something you want continually. You want to be feeding microbes in the soil 24/7.
Okay.
So anytime, just, don't overdo anything. It's hard to overdo biostimulants other than when I talked about seaweed and kelp. It's usually more is good, to a point. You can overdo, it's easy to overdo stuff in gardens. Like I put way too much compost last year on a garden. It ended up being the equivalent of 500 tons to the acre, so 4 to 6. That's, you're knocking off carbon to nitrogen ratios and things like that. So you can, but as far as putting a biostimulant, usually a little more is good or better. It's not like a pesticide or a fungicide, insecticide where, dead is dead. You spray enough of a Lorsban or a malathion or something to kill a bug. Once he's dead, he's dead. But with biostimulants, a little more food is usually feeding a few more microbes. So that's kind of how I look at it.
Okay.
So we're focusing on feeding the soil, not the plant.
Well, you're actually, and that's a good point, because I was going to bring that up. That's really, when we do this, that's what we're doing. We're feeding the soil, and at the same time, we're feeding the crop. So the crop can take up these organic acids. When I talk about cover crops, and I talk about what they're exuding, what they're putting out to feed biology, they're pumping carbon into the soil. And when we talk about that, when most people like me talk about it in a presentation, they're generally saying sugars and carbohydrates, and you might throw in organic acids. This is something when I'm meeting with clients and all, you can't read it, but this is a list of all the compounds that are in a root exudate of a plant, and it's organic acids and amino acids and B vitamins and phytochemicals, and it's all these things that's what the plant's putting out. And so and there are products like that. So there are products, there's low molecular weight organic acid that are good biostimulants. So we're kind of simulating what the plant wants to do in nature. But for a plant to put out these exudates, which is a biostimulant, which is the signaling mechanisms for them to wake up a microbe and have them get what it needs and bring it back. As they're doing that, to do that, they already have to be pretty healthy. So if they're struggling if they're not in the best of condition, say like a sick citrus tree, they can't afford to put out the root exudates to wake up the biology. So that's when we, as conventional farmers or any farmer, can add something to wake up that biology. And it can be as simple as a simple sugar, like molasses. I've learned over the year, I used to use a ton of molasses, and it's cheap. It feeds bacteria very well, beneficial bacteria. It's not the best probably for the fungal organisms. They like other stuff. They like fish and kelp and other organic acids. But with simple sugars, they also feed bad guys. So if you go overboard on a molasses or any kind of sucrose, fructose, if you go overboard, you can wake up pathogens and feed them also. So the more complex, the longer chain molecular structure of whatever you're using, the less likely that pathogens are able to feed on it too, and you're waking up the guys you don't really want to wake up. So that's kind of my take on and my spill on molasses and simple sugars. Fulvics and humics, it was been said by some of the gurus in the old and way before me that that's kind of more of a fungal food, which are the really hard ones to get going and keep them. They hate chemistry, they hate herbicides, they hate pesticides. So if you're having to do that in a system, it's hard to keep fungal guys going, alive and helping you. But like I say, I lean more on these low molecular weight organic acids. It's but anything that's liquid, that's carbon, that feeds biology, for the most part, it's good to add it into a system.
Okay.
And I don't know if I answered the question.
I think you did. I think you led to an even better question. So what you're saying really is, there are recipes, right? You don't want to just rely on one thing if you can. So you've got all these different things, and there's a million different ways to do it. So how do you do it, right? You've got most of the stuff you're talking about is liquid or liquid soluble. So what's the best way to, you make a concoction, right? A lot of people call it teas. So you take it. So how do you put together a tea? What's essential to making a concoction?
Yeah, that's diving into the inoculum, and that's the fun stuff. When I was doing my research on 5 acres for all those years, I mean, I made tens of thousands of gallons and had a microscope, and I haven't had any formal training, but you can YouTube enough and study enough and look at enough stuff, you kind of figure out the difference in a bacteria and a protozoa and a nematode, and the good guys from the bad guys. It's pretty easy to. So yeah, the compost tea is, I mean, that now you're making microbes, and there's a lot of different. What I was doing was an aerated compost tea, so it's aerobic, which takes a lot of air, a lot of oxygen through the whole process. So you would have a compost, and the better the quality of compost, the better your compost tea is going to be. Whatever biology is in that, not all of them will split and replicate, but for whatever biology is in that, that's what you're going to make more of, and then add them to your farm. If they're not in there in the beginning, you're not going to make them. So the better quality it is, the better your tea is going to be. So essentially,
when you say, I'm sorry, Brad. So when you say you're using compost, you're not just tossing it in a bucket, right? Are you putting it in I think of a tea bag, right? Are you mulching it in something? And so it's not just dirt flowing, chunks flowing everywhere, right?
And you can, but that's typically not how it's done. But yeah, like I had a commercial machine that I bought. I have blueprints. You can make it out of PVC pipe. So when I talk, they have 5-gallon bucket kits, but for more commercial size, like I was using a 250-gallon, shuttle tote that you cut the top out of, and then you have the system that went to the floor. And
yeah, a lot of people.
Big. You can do it with a jacuzzi pump. Like I say, I had a very expensive system I bought 9 years ago when I started doing this, because it was easy to clean. It was all stainless steel. It had real couplings, because cleanliness is a big deal. When you make a batch of this, it takes 24 to 36 hours. When you're done, you have to clean that machine if you're not rerunning batches continually. And so cleanliness is a big deal. So but yeah, essentially all you're doing is you're taking a compost, and it'll be like in a tea bag kind of situation, and that's going in the tank. And then there's a lot of air, takes a lot of air. I forget the cubic feet per minute, but there's a formula for it. And then that's just aerating the water. It's tickling the microbes out of the tea bag essentially. And it's predominantly going to be beneficial bacteria. Bacteria can split and replicate. They're not making babies, they're just dividing. So they can split and replicate like every 20 minutes. So if you do the math on that over a 24-hour period, where 1 goes to 2, 2 goes to 4, and then each of those are doing the same thing, you're talking about making millions and millions in a 24-hour period from one single bacteria. And then you got billions and billions so you're really exploding that. And it just depends on what you're trying to do. I used to make a lot of protozoa teas because I was told that earthworms like to eat protozoa. They're a bigger organism that actually eats the bacteria. They're good at cycling nutrients, cycling nitrogen. So there was a guru that said, and it worked. I would take alfalfa hay, and that would be part of my tea bag concoction that would go in with the compost, and that would tease out and feed the protozoa. So I had a certain thing I was trying to do in that instance. I was trying to feed earthworms. So, but my main concoction back in the day was just I made my own vermicompost, and y'all have had podcasts about that. So I made my own earthworm compost, which has a lot of critters in it that aren't in any other kind of compost. And then I would take that, I would go into the woods and get some native soil out of the old growth forest with some native species and put that together, throw a little fish in there and mix it up to give them something to explode on, maybe a little bit of molasses, and let that sit for a few weeks. And then I had this really diverse, concoction with all kind of goodies, and then just try to grow everything I could grow.
And that has a shelf life. When you're making that tea, you want to get it into the soil within so many hours, or is it days? How's the shelf life on that?
No, good question. And that's kind of the downfall to aerobic aerated tea is I would always get mine out immediately. I mean, I had the tank still aerate, and I had a transfer pump going into the tank. So, and then that was but I think the rule of thumb is 3 or 4 hours, ideally. I know people that kept it 24 hours. Some people, and I've checked it. I mean, I've let it set and then checked it to see if it was still alive with a microscope. And as you'll start getting, as the oxygen levels drop, you'll start getting anaerobic biology. You'll start forming ciliates, and those are kind of the bad guys. Those are the guys it'll have a bad smell. I mean, you can smell it. If it doesn't smell right, I wouldn't put it out. So that's right. Your nose it should just smell like virgin soil. When you go out in the forest and smell all that actinomyces that's in old growth forest soil, that's what it should smell like. So that's one form. That's the fun one to do that. And the longer you do it, it'll change. You'll get more protozoa. Nematodes will be in there. Beneficial nematodes. They won't split and replicate. So that whatever good nematodes are in a tea, those are just what came out of the compost. There'll be a lot of fungi. Won't be mycorrhizal. Mycorrhizal won't split and replicate in liquid. It's got to have a root host to grow and do its thing. So it could be in there and it could stay alive, but you can't grow more mycorrhizal fungi in a compost tea.
Okay. So you're just mixing that in to be distributed with everything else.
Right. Yeah. You could add it for sure, but you're just putting it as a carrier to go out with and there's as we make compost tea, you have to feed them. I didn't mention that, but as you put your tea in, then you got to add, I used to use a little bit of a molasses, a little bit of fish, a little bit of seaweed. So those kind of things, because you got to feed them, and you can overfeed them, and you can Google all this, people that want to do it. But just, just if it smells bad, don't put it out. That means you just did something went wrong. And the main driver is to have enough air.
So air is a big deal. If you have a smaller system, can you use like some aquarium bubblers and things just to get it going, or do you think that's not strong enough for your aeration?
Yep. No, you can, and I know people that have done that. Get the biggest bubbler you can get. Another form of tea, and I haven't done much of this. Are extracts and slurries. So you can take a good compost and just run water through it and just keep running water through it. And that's going to, and through a screen, right. And that's going to pull the microbes out and put them in that solution. They say those you can store some of them for months. So there again, I'd go by the smell check, or really the best way would be a microscope check, just to make sure, if you're going to do that. And then you can spray that on like as a foliar. And that's why you would, when I used to make the teas, I did about half and half when I was doing aerobic. A lot of it went on foliarly, and a lot of it just got pumped out through the irrigation, went on the soil. And then slurries is more of just mixing it with water, and then you're just taking off the finer stuff. So that'll be a little chunky, but you're going to get more carbon. You're going to get more chunks of stuff, but you could still filter that slightly and spray that on. And that's a good way to do it. And that can be stored for a little while. So that's kind of most of the rundown on the compost teas, I think. Like I say, I love doing it. It's a lot of fun. It's not done a whole lot commercially. When I first got into this 9 years ago, actually been 9 years this month. But when I first started studying all this stuff, I really thought I'd be consulting how to grow swimming pool size compost teas, and that's done. I've seen that in action. There are people with thousands of acres that have these huge swimming pool tanks, and they make compost tea and apply it and do great things with it.
So I just want to touch on one thing, because you said that vermicompost or worm castings is really good tea out of. You get some things that aren't in other stuff sometime. Yep. So for folks that don't want to raise worms, and it's not for everybody, you can buy rich in vermicompost worm castings in a big bag, and it's expensive, right? So to me, a good takeaway here is if you're using it to make tea, you're able to use that in a lesser capacity than trying to pour it all over everything in your garden, especially if you have a larger garden or a grove. But you're still getting, because you're using it to create more and breed more of those, those organisms. You're getting a lot further for your buck with something like buying a worm casting. So I think
you're getting the biology. You're not getting in compost. In the volumes, you're getting the biology, you're getting the carbon, and you're getting fertility. I mean, there's nutrients in, that carbon. So when you're doing teas, that's a good way to take, because some vermicompost, I mean, there's all different kinds and grades. There's stuff that's made out in California by experts that's not distributed across the United States. It's $1,000 a yard, $2,000 a yard. So I'm sure it's really good, diverse compost. So you could take, a gallon of that's then that only costs $10, and then that's got really good diverse biology in it, and then tickle those guys out, split and replicate those, and then you've got a really good high quality different forms of biology. You send them out with a lunch box, when you're spraying those out, give them some organic acid, some fish, some kelp, give them something to eat, when you turn them loose and set them out there. But yes, you are exactly right. The better the quality of your compost, the better your tea is going to be. So don't chinch on that. Get the best. If you're going to do that, get the best you can get.
And then to me, it's kind of like if you've got that nice culture, and I think we'll talk about testing in a different episode, but your soil's got this nice life, and maybe in a second you can talk about what are some signs, if you can tell without using a microscope. But once you've got that in the ground, you feel pretty confident you've got a nice soil biology going. Then it's like the world's smallest ant farm, right? You've got to put sugar in the ant farm or all your ants die. So you've got to keep, even if you have that good biology, it doesn't sustain itself forever. That's where the stimulants come, right? So that's where you've got your fish or your carbon-based things to put on them so they can eat and keep living, right?
Right. And as I've gone on through my career, in the second half of this stage of this part of my career of my life, I've actually learned it's really more. I do use a lot of inoculants. I have bionutritional fertilizers that have lots of yeast, lots of trichoderma, all the different forms of bacillus, task-specific microbes, and they do a lot of good things. But whether it's the stuff I sell or molasses or kelp or fish, really the main goal is just to get available carbon in the system, because the main goal is to wake up the biology that's already in your soil. You've got this indigenous biology, and even if your soil is overworked and doesn't have much carbon or organic matter and it's poor, they're still there. They're just sleeping. They're not up and working. So it's really more about getting labile carbon into the system to wake up the good guys. Because you got to wake up a lot of them. Just having one or two of this guy and one or two of this guy, they have, it takes a big bunch of them to do their job. So it takes a lot of food, and that's why I like doing it, putting some kind of a biostimulant in an injection system or an irrigation system and pumping that out, especially with your fertility. And we can talk a little bit about nitrogen and the importance of carbon with that, whether it's in this podcast or another one. But yeah, just feeding, getting the food out, and just nature will wake up the ones that need to be woke up.
So what's a good way, Brad? I know you know people who've done this a while can see it in a microscope, but if you've got a garden and you're trying to do some of this regenerative process or a grove, what are the signs that, are there signs on the ground or in your trees or vegetables and plants that say, you can look at it and say, I think my soil's doing pretty well, versus something that says, ugh, we could use a little more of this because they're not looking so good?
Yeah, just as far as the soil, I mean, almost any time where I put out an inoculant or a biostimulant or put a layer of compost, you come back the next morning, you start seeing, mushrooms popping up. Everybody, that's what they call me. Said, "Oh man, we're doing good. I got mushrooms," and you are. I mean, okay. They're a fungal guy, and you woke those guys up. A lot of it you can just tell by smell. I mean, it's a handful of soil. If it doesn't smell like anything, there's just not a lot of life in it. If it smells sour, then there's probably some anaerobic bad things going on. And then if it smells like the soil in the woods, then you got some good things going on. So that's just, and then you got to have fertility, in a garden situation. I like to use pelletized chicken manure. That's what I use in my small areas. And then biostimulants. And I don't do a lot of testing like in my garden, my fruit trees at the house, because it's just not feasible to do that, cost effective. So I just kind of go a general, you can use NPK fertilizers, if you're putting carbon in the system, it's not going to be that harsh. And that's what I was going to touch on. Anytime you're applying nitrogen in a system, especially liquid, you want to have some kind of available carbon with that, because there's just that carbon and nitrogen ratio is kind of a thing. But microbes are feeding on carbon and nitrogen, and so if you're always adding nitrogen and you're not adding any kind of available carbon, then they're depleting the carbon that you have in your system that you're trying to build up. So it's just a little bonus, a little kick. You give that with your nitrogen, and then you're not depleting the organic matter that you're trying to build in your farm or garden.
So I'm rather new to gardening, and I have raised beds, and I have 6 or 7 different kinds of fungus growing in every week I go out there and there's something new. This week there was little red circles that were all over. Last week it was like, we looked it up, it was like a dog barf type of, all over. And it's on my it's on my plants too. I mean, it's all over. And then I've had the little tiny white mushrooms pop up. I mean, I've just had so much. And it's our first time using I do a lot of cooking. So we have a lot of compost, and then we mixed it with the soil, and then we filled the beds. So, and I have a lot of vegetables growing now, but I have tons of fungus. So is this now a good time for me to add more fertilizers or feed to the plant, or is that telling me that I don't need to do it now because I have enough funguses moving through there that it's healthy?
Yeah, you're probably, typically in a raised bed or even at ground level like my garden is, typically we put a lot, you have a lot of organic material in there. I mean, it's probably, if you tested that soil, it would probably be 10, 15, 20% organic matter, maybe more. And you can't get too much and cause problems. But if you're in those situations, I just kind of let my plants tell me, if they're looking healthy, you don't need to do anything.
Okay.
But you could get some nitrogen drawdown and other nutrients because you have so much carbon. So you might need to side dress a little bit of a NPK fertilizer just because you have so much carbon in the system. But
Okay.
if you see anything fungal growing generally on the soil, especially, it's just good. There's nothing bad. I'm not saying go out and eat those mushrooms. I don't know what they are, but
Well, they ended up disappearing and going back in, but every week it's a new kind. And I'm like,
yeah,
what's this one? Little red
yeah,
dots. I don't know.
yeah. Things are changing. I mean, that carbon's breaking down all the time, and as everything changes, the ratios, it just wakes up a different organism. There's some that like this much carbon and in this ratio, and that just wakes up. Same way with like your weed seeds in in a garden. As things change in your farming system, you'll have some weeds go away and a new guy pop up. And not to go down another rabbit hole, but typically as we make our soils healthier and better, a lot of the weeds that really give us problems kind of go away, and the ones that come back typically usually they're not so invasive. So that's just a little side note but kind of the same thing. It's just the conditions are right for that guy to wake up, pop up, and then when he breaks down, he's just adding carbon back to the soil.
It's its own special little world going on under the ground there. That's just amazing. It's amazing stuff. It's a great deal. All right. Anything else you'd like to add? What else do we need to cover? Stimulants.
Yeah, I think, and that's kind of not the takeaway, but in my world, like I say, I sell a lot of different forms of biology and in the fertilizers I work with, but it's really about feeding what you already got there, just giving them a lunchbox. I do like to talk about yeast. Yeasts are in the soil. They can give us a lot of nitrogen. They can grow naturally. There's probably 200 pounds of yeast to an acre in just your average soil. But they're a good form of protein nitrogen or nitrogen or organic nitrogen. They're very fragile. They're kind of fungus-like. I add them a lot to things and then send them out with a lunchbox, and they can replicate and multiply. But if you can feed and grow 1,000 pounds of yeast in your soil, and you're going to hear a lot about yeast in the future. But if you can grow 1,000 pounds on an acre, that's about 420 pounds of protein, which is about 67 units of nitrogen. Very good, pure plant immediate uptake with no drawdown nitrogen. And you can account for that on your, if you need 200 pounds of nitrogen and you're growing that much yeast in your soil, you can take 60 or 70 pounds of nitrogen off your fertilizer budget. And with what fertilizer's doing today, I mean, that's a huge deal. So anytime we talk about yeast and the fungal organisms, they're the hardest ones to grow and keep going because they're so fragile. They don't like cultivation. They don't like nitrate fertilizers, really any kind, even sulfate fertilizers. Almost all fertilizers that we use in commercial production dings the biology. And it's the fungal guys that do us the most good, but they're the hardest ones to propagate and keep alive. But if you can, I mean, that's like free nitrogen, So those are something you're going to hear more. And a lot of the people that are selling yeast, most of it is just the same yeast that they make beer out of. I mean, it's those kind of yeast that can go into the soil and be grown and replicated. There are other yeast. There are native soil yellow yeast and blue yeast that go on the foliage, but that's kind of one thing that that I think is going to be big in the ag world is more focused on these yeasts in the soil. They do a lot of things. They grab a hold of nitrogen and keep it from leaching, and blowing off into the atmosphere. It's like a little lipid, like a little life preserver. So they can hold on to it and keep it from moving, and then convert it into a usable form. So anyway, that's my spiel on soil yeast.
Now, if someone wanted to add soil yeast, is it the same way as you said? I know you said you could add mycorrhizae into your slurry or your tea.
Mm-hmm.
Could you do that? Just scoop of yeast as well? Does that work?
Yeah, you could. Yeah, you could. I mean, and there's products out there, not just what I do, but there are a lot of ag products that have yeast in them. And I'm just saying that's one I really like. I mean, I like all the task specific, the trichodermas. There's a lot to help with pathogens. There's bacteriocins. There's all these things, and they're wonderful. I use a lot of them, but yeast is the one. If you can get those guys going and working, that's where you can really, give your plants. You knock that off your fertilizer budget, but then your plants are getting really, really good energy, that they are good nitrogen source that's in a form that they don't have to exert a lot of their energy to convert it. It's already in the form that they need naturally.
Nice.
So,
okay. So look for some yeast on the label if you're buying inoculants and stuff. Okay, cool.
And then I did want to talk real quick just about the foliar side of all of this, because people typically don't think about the biology and the carbon on the outside of the plant or the inside of the plant, but the outside of the plant is covered in all forms of biology. It actually literally can even crawl up the plant, and do that. So I'm always thinking about feeding, getting carbon on the tree, on the plant, on the crop. Compost teas. Well, I mentioned I would put them on foliarly, but that's a big deal. Building that biofilm as a protective layer on the fruit, on the leaves, on the stems can help a lot with controlling pathogens.
Can I ask a question? So certainly. You're talking about pouring the stuff or sprinkling it to where it's going to be on the actual plant and the leaf and the fruits and the flowers, not just in the ground. Like most of the stuff we just put in the ground when we're watering. Right. You don't water on the tree, you water on the ground. Right. So you're saying
put it everywhere.
Okay.
If I'm here at the house and I've made and I use my stuff, that can go on the ground, but I put it, if I'm doing a watering can, I'm going right over the top of the tree and letting that rain on that, and then hit the soil, and then watering into the soil if you want to, especially if it's a homemade tea. You want to get them kind of in the soil and protected. But yeah, you're just, and there's some biology that's more for the on the plant and more that's for the soil. The stuff that I work with, I have some that's a blue yeast that's more for the foliage that's exposed, and that's what it's designed for. And then that occurs naturally also. And then there's yeast and microbes that are more for the soil. But just put them on there. It's not going to hurt anything to put something that probably isn't going to survive on the plant. If nothing else, it's going to be food. It's going to be a plant metabolite that another microbe can eat as nourishment. And then there's, even in dead microbes, that's not necessarily a bad thing, because the metabolites are still there. The food is still there. So even in compost, a lot of that biology has died and is dead. And I always say it's not necessarily a bad thing, because the metabolites are still there, the goodie, and the food. So it's the same way on the plant. Just pour it over the top and let the rest go in the ground, and the plant will take some of that up. And it'll just act as a protective layer.
Okay, so all over. Make sure you get it in the ground, but you can also hit it up high with the same kind of teas or liquid concoction.
Pretty much. Yeah, there's a lot of people that used to spray foliar fish. Some molasses would go on foliar. Fulvic acid, I think, is more. It's a finer grade than humic acid. A lot of that will go on foliarly. Like I say, I work with low molecular weight organic acids, which is like lactic acid, citric acid, tartaric acid. And those are made from like a microbial fermentation where we're kind of replicating what the root exudate is. And that's where the technology is going in big ag. I kind of got onto it a few years ago and started learning about it. And there's not a lot of people that understand it and know about it yet, but there is some technology that's out now and more of it is coming, where a lot of these things that we buy is very replicable to that sheet I held up with all those phytochemicals and components. And that's just a bridge just to help us. Our soil's not that great. We need to get the plant functioning on all cylinders immediately. And then that enables your crop then to have reserve energy that it can pump into the soil, feed biology, and then it's getting the exact thing it needs. Because like I said, the plant and that microbial population is really the only thing that knows exactly what the plant needs, so that's how I help growers, not cheating. It's just trying to replicate more what's happening in a natural setting. So the plant that's why I used to say foliar in my early days. I said foliar sprays I called them a crutch, because you weren't really fixing soil. You were I would look at a tissue test and put on what the plant, said it was lacking. And I did that just to get, the plant healthier and producing better. But what I learned later, years ago, was at that time, now it's got a reserve of all this energy. And what it wants to do is pump that out into the soil and feed the microbes, so they'll get that symbiotic thing, back and forth. So that's why I love foliar feeding. It's a big deal, but that actually helps feed soil.
Excellent. Insightful. Very good. All right. I think we're about at time. So unless there's anything else you want to add, Brad, we'll maybe wrap this up, and then we'll hit the next one next time.
I think as far as a closing statement, what would I say? I would say really agriculture, all agriculture, it's really about managing disturbances. So that's, you're always disturbing soil with almost everything you do. It is a disturbance. And so you're just trying to minimize those disturbances. And that's part of adding, inoculants, and, you've done some disturbing. So let's add something good back. And then what I always say is if your soil isn't living, it's dying. There's no in between. You're either growing it or you're killing it. It's never just stagnant in one place. So you always kind of think about it like that. If I'm not doing something, adding carbon, biology, whatever, to make it grow, then it's dying. And that's kind of the simple way to put it.
Okay, very good. So your advice is that it's not a one and done. You got to keep up on everything and make sure everything's consistently working. Very good.
Yep.
Awesome. Thanks, Brad. So that's about all the time we have for today.
So thanks for listening to the Modern Farming Podcast, and be sure to follow us, share, and join us again as we grow knowledge about the world that feeds us. Thank you, Brad.
Thank you, Brad.
Thank you.
Looking forward to your next one. Looking forward to your next episode. Awesome.
Excellent.
Thank you.